This cube is pure white, but clearly it's blue on your screen. This is because the default lighting environment in Godot is not very attractive. Under the default settings, your materials look flat and muted. Hey guys, my name is Corey, and in this video I'm going to show you how to set up lighting in Godot for outdoor environments where you can see the sky. I'll show you how to light your scene with a high dynamic range image, how to light your scene with the built-in Procedural Sky, or how to light even if you're using your own shader for a sky. If you're working in small static environments like an indoor scene, you should use baked lighting or a GI probe. Both of these tools require defining a fixed finite space, so we won't be covering them in this video. However, the concept here will definitely help you. What we will be covering is essential for large open worlds, as you've seen in my other videos on voxel terrains. So let's get started. I want you to adopt a lighting workflow in all of your projects. I'll keep referring to this throughout the video, so keep it in mind. First, you're going to define your color transform. In Godot, this means choosing your tone mapper settings. We'll look at this in the HDRI section in part 1. You want to do this first because it directly impacts how you set up your lighting. Second, it's important to white balance your camera. In 3D, this means just using white lights. So unless you have a specific reason to, such as making a fire effect or sunrise or sunset, don't color your environment lights. Colored lights just mess up your color transformation and make it difficult to work with color in post-production. Step 3 is to set up your lighting and exposure properly. Finally, after you've perfectly lit your scene with neutral colors, then and only then apply your post-production effects, including color grading. We have a brand new project. I'm going to create a 3D scene, and quickly I'll work through setting this up. I'm going to use a mesh instance to create a cube. Then I'll create another mesh instance for a plane. I'll lower the plane so that we have a little bit of space between the cube and the plane. That's so that I'll be able to get a shadow and be able to see it between the two objects. And you can see that the plane and the cube just have a basic default white material, but on screen they are blue, and that's because of this heavy blue cast from the sky. We're going to be learning how to neutralize this effect in this video. Once you start applying materials, things look different. I've continued fine-tuning my settings under various lighting and material conditions. The text overlays show my best recommendations. We'll review all of the settings at the end, and remember, these are just the best overall defaults, so adjust them to fit your scenes. You may have been taught in Blender or other 3D applications that you can light your scene by setting a high dynamic range image in your background. And indeed, here we are in Blender, and the HDR has created a very nice lighting effect. There's a nice soft shadow underneath the cube. But this is using Blender's ray-traced engine called Cycles. If we switch over to Blender's real-time rendering engine, Eevee, the shadow goes away. And this is just a limitation of current rendering engines. Godot has the same limitation. Now let's continue setting up our scene. I'm going to add in a world environment node and parent that to the root. Now this background is coming from this default environment.tres. If we go into environment and choose new environment, you can see under background, I have a clear color by default. This clear color is coming from project settings, rendering, and then environment. If I drag the default environment file over to the environment field, you can see we have the original look. So I could edit directly in here, but I'm going to choose a new environment. Under background, I'm going to choose sky. And then under sky, I will choose new panorama sky. Under panorama here, I could choose load and then go find an image, but I'm going to drag one in from my file system. I have an HDR here. I'm going to drag this in, and here we go. Now I have an HDR in the background. And we can see, just like in Blender, there is no shadow. I also want you to look at this background. If we were standing there in person with the sun this bright, would it really be this dark? My eye says no. So I'd say for this particular HDR, the exposure should be between 2 and 4. And playing with it, I actually decided to set it at 2. Not all HDRs need this. Next, I want to look under Tone Map and Mode. This option tells Godot how to transform light from linear color space to sRGB color space that our monitors are using. Blender uses Filmic, Unreal Engine 4 uses ACES, which is a little more contrasty. My general recommendation is Filmic. Any of the bottom 3 options are acceptable. Look what happens when I select Filmic and then increase the white point. Watch the sun in the background image. If I choose linear, white does nothing. Here's what Reinhard looks like, and ACES. It is a little more contrasty. So I'll set this back to filmic. My general recommendation is to use filmic, leave exposure at 1 unless you need it for the HDR, and then set the white point anywhere between 4 and 16. Next, let's look at ambient light and see what happens when I adjust the exposure. It changes the background and the light that affects the models. The white point also affects both, but it is focused mostly on the upper ends of the exposure range. If we adjust the settings under ambient light, sky contribution affects only the model, same with energy. We're going to look at these settings more in just a moment. Now I want to take a moment and look at filmic inside of a real game application. This is the TPS Demo, and I want to focus on 3 areas. The first is going to be the robot's face. You can see how blown out it is. We're very close to the light. So we're looking at the robot's face. Also look at the front face of the vehicle back here, and then also on the ground. I'm going to adjust the white point 3 times. So the first time, look at the robot's face. Okay, let me reset this and now watch the vehicle face. Now you can see a little more detail has popped out. The third time, look at the ground, and you can see more details popped out here. Now let's look at the light. So we're looking up here. You can see how much glow there is coming from the light. By increasing the white point, that has decreased a lot of the glow, and that may have been the artist's intention. But we can fix that just by increasing the strength of the glow down here to 1.07. And even at that greater amount of glow, if you look at the vehicle front, there's still more detail there. I got a message from Jason Summerskill on Twitter. He says, highlights being blown out is a thing that happens in real-world photography. If you perfectly balance everything, it'll start to look fake. Jason is a lead VFX compositor who's worked on films such as The Avengers, Christopher Robin, The Witcher. My recommendation is to keep what he says in mind, but you don't just want to go with the defaults and let Godot blow out your highlights. You want to control every aspect of your lighting, and that means adjusting your tone mapper settings with values that make sense, and that usually means a white point above 1, probably centering around 4 to 8, or maybe all the way up to 16. Next, let's set up our primary light. In photography, this is called our key light. Let's add in a directional light. This is also how we're going to get shadows. And I'm going to leave it parented to the world environment. It's not necessary, it's just for organizational purposes. Let's move it out of the way so I can see it. Now you can see that the arrow is pointing towards the left, and so the light is shining on this face of the cube. Now if I rotate the light around, you can see how it affects the light on the model. If I look under shadow and enable it, you can see now we finally have a shadow. And as I rotate this around, you can see it changes the direction of the shadow. So in order to get an accurate looking light, we need to line up the shadow with the direction of the sun and the sky. So I could rotate this around and try to eyeball it. But let me show you a trick on how to make this pretty easy. So I'm going to move the light over and move it up into the middle of the sun. And it doesn't matter where the viewport is or where the light is. The only thing that matters is wherever they are, you line them up. Then we need to take this arrow and point it directly into the viewport camera. So I'm going to go under Transform. And you can see that as I adjust these values, it moves the arrow. I'm holding down Control so that I can move these values much faster. So in order to get this to point directly into the camera, I can tell you we don't need any Z value. So I'll set this to 0. Then I'll move Y around and you can see that those vertical lines merge. That's what we want. We want to turn this arrow into a cross. So let me adjust the Y value and then I'll adjust the X value and you can see, there we go. Now if we look to the side, you can see that the arrow is pointing away from the sun. And the shadow is now perfectly lined up with the sun as well. Now we can move this light anywhere we want, and it won't affect anything as long as we have the rotation. The rotation is all that matters. Next, let's adjust the exposure of our key light here. It needs to match what the environment looks like. So to my eye, this looks a little bit dark. If I go under light and then adjust energy, you can see how it impacts the model. Our materials are white, and with this bright sunlight shining on it, the objects should look pretty white. But they shouldn't be so bright that the faces of the cube merge together. So to my eye, one looks a little dark. I can also adjust the color and brightness of the shadow. But look at what happens in the environment when I do that. It only affects the shadow. It does not affect the shadowed faces. So use this only as a fine-tuned tool if you want to adjust only the shadows. Instead, I'm going to leave this at black, and I'm going to go back into the world environment under ambient light, and I'll adjust energy here. This is our fill light, our secondary light. It's also going to give us the effect of bounce lighting, even though it's fake. So typically what I recommend is to set the color to a middle value. Under value, I'd set this to 50, or RGB is going to be 128 down the list. Then I'm going to turn down the sky contribution. Notice what happens. You can see it removes all of the color. This is a key factor. It's taking the color of the sky and it's coloring the environment. This is what was happening in the default settings, which is why it was looking so unattractive. We're going to look at this a lot more in the procedural sky section. This still looks a little strong for me, so I'm going to decrease this somewhere between maybe 0.5 and 0.7 for this HDR. So I only have just a hint of blue in the shadows. And then I'm going to increase the energy to what it should look like in this environment. And I'd say maybe around here. Okay, this has given us an environment that is lit by an HDR, but I don't really like the look of this. I mean, we have a Ferris wheel and the stone ground behind our 3D object, so let's look at what happens when we use a different HDR image. So an HDR like this might be more effective, especially if we have a large landscape. And this isn't a very high quality HDR, but you get the concept. So let's look at what this HDR environment looks like when we reset all of the tone mapping settings. And you can see it's blown out, the clouds are turning cyan, and the sun looks like a massive lights in the sky. So let's go back to Filmic, and then increase the white point up to 16, although that might be a little high. Let's reset the energy and the sky contribution. And then now our directional light is facing the wrong direction. So let's reset this back into the center. And then we'll adjust the rotation so that the arrow turns into a cross, which means it's aligned with the camera and the sun. And there we go, except our model looks weird. Our shadows are in the wrong place. And if we move out to the side, you can see what's wrong. There's actually two directions that arrow could be pointing in order for it to turn into a cross. One is towards the sun and the other is away from it. So there's an easy fix for this. If we go under X and add in plus 180, it'll flip that right around. And if we go back to the sun, we can see that it is indeed still a cross. And if we look at our model, now the shadow's pointing in the right direction. Okay, let's reset the energy. And now let's look at lighting with our primary key light. Okay, now let's go back to our bounce lighting. As far as the exposure, which I probably should have done first, I don't think it needs to be any brighter. We can look at it a little bit and see maybe a little brighter or one. For this HDR, I think it's fine. Okay, we've already set our key light. Now let's adjust our fill light. The color is still a middle gray, so I'm going to reduce the sky contribution. And you can see that it doesn't really add in a lot of blue. It's not too heavy. So I think a sky contribution of 1 is actually fine here. So now let's adjust the energy to see where our shadows should be in this environment. It's definitely not going to be as dark as 1. So if I bump it up, it's probably somewhere around there. Now, I still don't like this look of the HDR in the background. I mean, if we increase the size of the landscape up to 1000, something like this could work. But look at what happens once we get some elevation, and you can see the lip of that HDR floating around. I don't really like it that much. So if you're going to do this, I'd rather use an HDR that looks something like this. Here, I've taken that desert scene and I've edited the bottom. I've just basically cloned the sky from the top to the bottom and then smoothed out the seams. If I bring this into Godot, you can see now I have just a cloud and sky background. Let me turn off this grid and then move the camera down. And now we just have a sky background. This is an environment that I would actually use. So all you guys who are making tutorials and demos, I recommend that you use an environment like this. Just have a landscape-free HDR in the background so that your scene can just focus on your 3D objects. Now that we've set up this environment, let's save it. If I click here and choose Save, and then I'll call it HDR Environment. Now we can switch between environments. If I drag in the default environment, we have our Procedural Sky. If I turn off the directional light, you can see we're back to where we started. And then I drag in the HDR environment, turn on our directional light, and there we go. Now let's look at lighting with the built-in Procedural Sky. So I'm going to go to the world environment and choose New Environment. Then I'll go to the directional light and reset the energy level, and then I'll turn it off. Back to the world environment, under Background, I'm going to choose Sky. And then under Sky, I'll choose a new Procedural Sky. And here we are, back in the default environment. Under Tone Map, I'm going to set this to Filmic and then bump up the white value. Under Sky, I'm going to open up Sky here. Look at what happens when I adjust the energy. It has brightened up the sky, and it's also brightened up our models. Now let's look at the ground. And if we adjust the energy here, it also adjusts the value of the shaded faces. To be honest, this is pretty crazy. I don't understand why that happens, but I'm going to show you how to neutralize that. Under Sun, these settings allow us to change the position in the sky with latitude and longitude. We can adjust the size with the angle min and max, or the curve, and we can also adjust the energy. However, the energy does not get strong enough. If we bump it all the way up to the maximum of 64, this is not nearly enough to light our scene if you compare what it looked like with the directional light. These are white materials and these objects should be white. Now I can change the curve to get it brighter, but look at what happens with all these changes. I mean, I'm changing the energy, changing the strength of the sun, and it's changing the size of it in the sky. Now we could reset this back to 0, and if we go down to this energy field down at the bottom, this acts as a multiplier for all of the settings above here. So I could get a stronger sun by changing this energy to, let's say, 10. Then I could set this sky energy down to 0.1 and the ground energy to 0.1. And then if I use the sun energy value, it's now going to be 10 times stronger. And if I take it all the way up to the top, now we're starting to get to where it should be. But we still have a problem of the giant sun in the sky, and of course there's no shadow. And it's still kind of an ugly blue. Even though the sun is white, that blue is still seeping in. We'd have to change the sun to yellow to counterbalance it. And although this does happen in reality, it doesn't happen in photography, because in photography we white balance our camera so that the sun is essentially white. And it's very challenging to balance properly between the yellow sun and the blue sky. The other challenge with having a colored sun and a blue sky is that there's no bounce. We're not using a GI probe, so the bounced light is only going to get the blue from the sky, and it's not going to get any mixed lighting from bouncing. So I don't recommend you try doing this. Instead, just have your sun be white, and we'll reduce the blue coming from the sky with the sky contribution value. If we try to reduce this angle max to get the sun smaller, it reduces the energy as well. So we're kind of back to where we started. So really, with the current setup, there's no way to get good lighting from the Procedural Sky. So I'm going to reset all these values, and here's my recommendation. What we're going to do instead is set up the Procedural Sky only as a background picture with no lighting effects. Then we'll use our directional light and ambient light to actually light the scene, just as we did in the HDR setup. So I'm going to go into the sky and change the color to a nice blue. I'll say it should be around here, and you can see the values on screen. I'm going to copy this hex value and paste it into the horizon color. And then I'm going to reduce the saturation. And then I'll increase the value. I'll copy this. Then I'm going to go to the ground and paste it in here. And I'll go to the ground horizon color and paste it in here. So now I've effectively removed the ground. Now I'm going to keep the sun as pure white. Now you can adjust the position of the sun in the sky wherever you want. I actually want it to be a little bit higher. I'm going to set this up to 50. I want to change the sun energy to 30 and the angle max to 30. That'll give us a nice ball in the sky. Now under ambient light, I'm going to set the value to 50. So we have a nice middle gray there. And then for sky contribution, I'm going to turn this down, and this is going to neutralize the light from the sky. It's fine to reduce it all the way down to 0, but I'll allow just a little bit of color coming in from the sky. So on the procedural sky, my recommendation is a maximum of 0.3 to 0.4. And then I'm going to turn on the directional light, and that's starting to look nice. So let's position this. If I double click on the icon over here on the scene panel, it'll pan the viewport over to it. So now I'm going to move this into the center of the sun. And actually, here's a trick we can do with the procedural sky to make it a little easier. If I go to the world environment and then the sky, I can turn the energy all the way down to 0, and it'll turn into a little black dot. That gives us a little more fine-grained control. Now I'll reset the energy back to 30. You can see I've set the latitude to 50. What I can do is go into the directional light. I can reset all these values, and I can put in 50 right here. And it turns right into a cross. Except it's pointed in the wrong direction, so if I add in 50 plus 180, it'll flip it right around. And if you put in a value for longitude, you'll have to put in the negative longitude value for Y. Okay, let's adjust the value for our key light. Under directional light, I'll adjust the energy. And then I'll come into the world environment and adjust the energy of the ambient light. If I reset sky contribution back to 1, you can see how strong it is. It's unnaturally strong. So that's why I recommend a maximum of 0.3 to 0.4. And that's really all you need for setting up your lighting under a procedural sky. Now let's look at lighting if you're using a shader for a background. And it's going to be essentially the same. I'm not going to get into shaders in this video. This is just going to set up the lighting. And imagine what it would look like if we were using the default sky. It would be impossible to get these nice reds and browns out of the landscape with a strong blue cast from the sky. So let's look at how this works. The way this works is I'm using a panorama sky, but instead of using an HDR image for the texture, I'm using a shader. Here I have a sprite with a material. The material has a canvas shader on it. Here's the script that controls it. The texture is written into iChannel. The environment pulls from the environment sky.tres, just the same as I have over here on world environment. I already have a panorama sky set, so these lines are commented out. And then here I'm setting the texture to iChannel, which is the texture being generated by the shader. So the shader generates the texture, which is being applied to the panorama sky background. Here's my directional light. I know my light is coming from over there, and if I move my camera down, you can see that the shadow is pointing away from it. Now, one thing I didn't mention before is that under directional light, directional shadow, this max distance is important to be aware of. This affects your performance quite a bit. I have a GTX 1060, and I would typically set this between 200 and 400. The default is 100. This is basically how far away from the camera Godot will render your shadows. If you have an older card or an integrated model, you probably want to set this maybe as far down as 20 or even 0. So adjust it based upon your performance. Next, you can see that I have adjusted my shadows. I've lightened up my shadows specifically for this particular environment. Then if we look further down, you can see that I've set up the ambient light energy and I've reduced the sky contribution all the way down to 0. And then under tone map, you see I've already set the filmic and a white point of 16. So you can see the lighting setup is essentially the same as the other environments we've worked in. We've set up the lights properly. Now we can get into post-production effects. So here I could enable fog. You can see there's the fog in the background. Here I'll turn it on and off so you can see the effect. I can come down to adjustments, and this is where I could set up a color grade. Here I'll increase the contrast or the brightness. Just make sure your settings don't blow out all the nice lighting that you've already set up. Another thing we could do is change from filmic over to ACES or another tone mapping setting. ACES is more contrasty, and you can see here it provides a nice effect. All right, we've covered a lot of information. Let's review it all. First thing you're going to do when you create a new project is to set up your color transform. You're going to go into your tone map settings and choose Filmic, ACES, or Reinhard, and set your white point from 4 to 16. You're going to make sure that you always use white lights unless you have a good reason to. You're going to reduce your sky contribution to a subtle level. Next, you're going to go through and light your scene properly. If you're using an HDR, you'll set up your exposure first. If you're using a procedural sky, you're going to set up the sky background so that it looks reasonable. Then you're going to set up your directional light, which is your key light. This is your primary light, so make sure this is bright enough for your scene. Then you're going to go set up your secondary light, your fill light, under ambient light, and make sure your shadows look natural. Finally, you're going to go through and review all your settings again. Your directional light, your ambient light, the shadow color of the directional light, and then also review the ambient light sky contribution. Once you've properly lit your scene, then and only then will you come in and do the post-production effects, your depth of field, your brightness contrast, your color gradient, and hopefully in the future, Godot will support color lookup tables. Now that you have a decent lighting setup, I can finally start on shader tutorials, so those will be coming next. I hope you got some value out of this video, and if you did, I'd appreciate a like and a share. Let me know your thoughts in the comments below. Make sure to subscribe and follow me on Twitter if you haven't already. Also, I'm looking forward to seeing your games and demos with improved lighting, so tag me on Twitter when you post them. That's it guys, thanks for watching. I'll see you next time. Happy New Year.